Oh, hi everyone. Once again, Mitch from Arista, joined by my friends over here, Sanish and Hamam, HPE and Nokia, and we're going to run through exactly what the slide says, the very exciting topic of EVPN multi-domain interworking. So, let's get the party started. What is this thing all about? The test is really around end-to-end service delivery, as it says, across multiple transport and BGP address families. Meaning maybe we're going from MPLS to VXLAN, or we're going from IPVPN to EVPN for L3 VPNs. Take your pick. From there, we're going to have that end-to-end service delivery across those multiple transports and those service delivery mechanisms. In the test, we focused on RFC 9014, so the EVPN gateway functionality, doing the specifically focused on L2 VPN. We'll see today we went from EVPN MPLS to EVPN VXLAN, and then back at the end of our journey, back to EVPN MPLS. And then for L3 VPN, we did test IPVPN and EVPN interworking from a BGP address family perspective. And then also same thing here, going from MPLS to VXLAN back to MPLS. And then we'll see in the L3 VPN use case, we have this little kind of passport that's stamped on the route as it goes along through the different domains called a DPath. And we'll cover in detail what that's used for, but the little spoiler is that it's control plane loop prevention. All right, so the gateways, how do they work? High level, right? Specifically, so L2 VPN, gateway is going to scope that control plane state, right? So you think about your type 1s and your type 4s for multi-homing. You think about your type 3s. Those, once they reach the gateway, it is do not pass go, do not collect $200, you're not going anywhere. Not getting by the bouncer, right? The type 2 routes will be sent along, but only for MAC VRFs that are intended to be stretched between the different domains, right? So we start scoping our control plane a bit here, right? When it comes to the gateway setup, which leads into scoping the flood list. Those type 3s are blasted along, right? The gateway advertises its own, originates its own. So from a flood list perspective between the domains, it's gateway to gateway, right? We're not going from like PE to PE, VTEP to VTEP. For 9014, we have the Interconnect ESI, which is kind of like a logical construct. We have all the gateways multi-homed. You'll see in the demo we have a site with 2, we have a domain with 4, and then the usual suspect supply from a multi-homing perspective, right? So we have a DF election, split horizon for bump forwarding, all that fun stuff. Layer 3 VPN, we are just going to re-advertise a type 5 route, and we're going to see that the DPath is stamped on there, and we're going to see in the control plane the tunnel NCAP attribute is updated as well as it goes along. This is the same for the type 2s, where it's going to say, okay, tunnel NCAP was VXLAN, now it's MPLS, now it's VXLAN again. Ah, yes, the big question. But why? Why would one do this? 3 primary use cases for kind of starting this party here. Migration. Maybe we're going from IPVPN to EVPN for L3. Cool. Maybe we're going, migrating from MPLS to VXLAN or whatever the case may be. Cool. Right? We can do that with this. Same thing for the seamless transport interworking. Maybe we have a couple data centers that are running VXLAN and they're interconnected by an MPLS WAN and MPLS core. Great. We can extend L2, L3 end to end across that core between VXLAN and MPLS. And the last one, really important one here is scaling. So maybe we have an environment that we can't just slam everything into one big EVPN domain, right? We want to scope and have a sense of hierarchy between maybe different areas of our network to control the routes floating around, the MAC addresses, all that fun stuff. And with that, I'm going to turn it over to Sanish to cover this wonderful topology. Just a few things going on there.
Thanks a lot, Mitch. Yeah, basically this is the topology which we used for the interworking demo, right? So there are 5 domains here. If you look at the left-hand side, top and right-hand side, right? Those are all the EVPN MPLS domains, right? And the bottom portion is the EVPN VXLAN domain. So all those 5 domains, right, are connected with the VXLAN fabric at the center, right? So there is one more way we can visualize this one. So if you look at here, this is our EVPN MPLS 1. This is EVPN MPLS. This is also EVPN MPLS, right? And on the bottom portion, we are having EVPN VXLAN 1, right? So all these 4 domains are connected with the EVPN VXLAN fabric. That is one way to look into the fabric connection, right? Another way is something like there is a EVPN VXLAN domain, right, connected with the 3 EVPN MPLS domains, right, so that VXLAN got interconnected with the MPLS domain, right? Now, if you look at this one, on the EVPN MPLS side, we are having the IGP as the ISAS protocol, which will help to get the reachability of the nodes. Once that reachability is available, right, what we'll be doing, we'll be having the overlay network of the EVPN signaling, right? So within the EVPN MPLS domain, ISAS forms the IGP1, then the overlay is the BGP EVPN1. And if you look at the VXLAN one, which is connecting all this EVPN MPLS as well as the bottom EVPN VXLAN one, we are having the eBGP protocol as the underlay. That means all the network nodes are reachable through the eBGP one. Once the nodes are reachable, right, then we are having the overlay with the eBGP as well, right? Now, on the left-hand side, you can see here, this is there is 2 nodes from Arista. 2 nodes from Arista playing as the gateway functionality on L2 and L3. And on the top, you can see there are 1 node from Arista and 2 nodes from Cisco playing as the gateway functionality. And on the right-hand side, there are 4 nodes, 1 from Nokia and 3 nodes from HP playing the gateway functionality. And on the bottom portion, we are having 2 nodes from Arista playing the gateway functionality. So that's all from with respect to the topology, and Mitch will explain more with respect to the type 2 and type 5 interworking scenarios. Back to you, Mitch.
All right. Cool. Check. Hello. Maybe. Oh, there it is. All right. Let's see. We could keep looking at the slides, or let's go ahead and take this, and boy, this is going to be fun, and take a look at this at the CLI, because who doesn't like looking at the text here? So let's go ahead and go over here, and we're going to take a look at this diagram, and we're going to go kind of left to right, looking at the control plane from a layer 3 VPN perspective. So if we kind of go back over to the diagram, we're going to see that from the left-hand side, we're going from the PE node to the gateway, across the core to the other gateway, and then to the PE node in the remote domain. So let's go back here, and let's start our little journey end to end. First, let's make sure that this fun stuff is showing up. Awesome. So delete all that. All right. Cool. So let's go ahead and take a look at the route that's being originated by the PE node. Let's move this little guy around here. Maybe. Never mind. All right, so let's go ahead and this PE node down here is originating the route that we're going to take a look at up here on the spine, right, this route reflector. So this route in particular is going to be this guy right here, and he is originating this route in particular right here. So if we take a look at this, and you know what's all on the route here. All right, so we've got the tunnel type, of course, MPLS, all good. Route target as expected. We see that we have the next hop as expected as the PE node itself. Nothing unusual, right? The usual suspects, they're all here. So we kind of clear this out and we take it another level over and look at the gateway node. Let's go ahead and scroll over, and we're going to take a look at the route that's now being originated by one of the gateway nodes. We'll focus on this one, and it's originating a route into the core that we're going to take a look at over here. Ta-da! It's originating this route right over yonder, right there, right? So what has changed in this route? Let's take a look. So what's changed, if we're taking a look at this thing, from what was originally received from the PE node, is that we now have a different tunnel NCAP attribute, right? So this is now saying, hey, this is VXLAN. And as expected, we then have the VNI, the L3 VNI that maps to the VPN. The next hop itself is also changed to the gateway node, and we see the gateway node has used its own respective RD and RT values. Worth noting that this doesn't have to do this, but I would we can change them and keep them the same, but there is the ability to change them. In this case, we did. So the route target originally was 2,000, now it's 1,000. But the big thing here is the tunnel NCAP has changed. We have a VNI, and then also spoke about this a bit earlier. There we go. There's that little stamp on the passport. Oh, okay, cool. Here we come into the WAN. We're going to advertise this type 5 IP prefix route, and we're going to add dpath to it to let the rest of the environment know that this route has passed through or originated from this particular domain. All right, so next stop on the train station here, and actually just reiterating that the type 1s, the type 3s, the type 4s, once those hit this gateway node here, right, let's go ahead and delete this. Once those hit this particular, either of these gateway nodes really, what's going to happen is they're not going to make it into the remote domains, right? You know, they're kind of hitting the bouncer. They're not getting into Club WAN, right? They're going to stop right there, and that's it. So at that point in time, we're sending the type 5s. We're also sending the type 2s for the extended EVIs, but let's keep looking at this type 5. So it's received by the remote gateway, and then once it's received by that remote gateway, it's then going to send, in this case, it just happened to be this particular gateway here, the Nokia box, all right? And then it's going to originate the route that we're going to look at over here. All right, so this route right here, heading into the remote domain. So looking at this now, let's go ahead and grab a little arrows here. We see, again, the tunnel end cap is back to MPLS. Notice dpath was added, so we have the dpath value that was from the originating domain. We also have the dpath value that was associated with the core. So we know all the different domains this has passed through, and it's important to note that when these gateways advertise, whether a type 2 or really a type 5 in this case, into their local domain, you know, that will come back. And the idea is that dpath is going to give us the ability to say, okay, hold on a second, I'm not going to send this back into the same domain that this has already passed through. So a loop prevention mechanism there. All right, but again, the gateway set the next hop to itself. RT values back to 2000, NCAP is MPLS, all good. So at this point, we now will have an end-to-end kind of control plane setup for the communication to this prefix. All right, let's go through the type 2, and then we'll hand it over for some show commands over on the HPE and the Nokia side. I'm going to go ahead and delete this, and let's scroll down to the type 2, and it's going to be very similar. All right, so let's come over here, and let's clear the screen, and let's take a look at the type 2 routes. All right, so kind of following the same pattern here, we've got the PE node that is originating this route right here. Cool. All right, and then we see we have the MPLS label, L3. We have the ESI that it's originating from. This is actually a multi-home PE node back here. Tunnel type is MPLS. And then we see the MAC VRF RT value. We see the IP VRF RT value because this is a MAC plus IP route in this case. And then we see the next hop is the actual PE node itself. So nothing too crazy here. The usual suspects are all showing up in the different routes. But if we take a look at the gateway node, so let's go ahead and delete this and scroll over just a tad here. We're going to see that something very similar that happened to the type 5 is now going to happen to the type 2. So again, we'll keep picking on this gateway node here. He's been a good sport and going over here. And this is originating the route into the core that we're going to see right here. Let's clear the screen, share bridge. And let's go ahead and bring our little drawing pad up and look at this route. All right, so if we look at the route, once again, we see it's no longer MPLS, it's now VXLAN. We have the RT values as expected. The next hop is, of course, the gateway. And we also see the BNIs as expected, as well as, in this case, the interconnect ESI that is that the two gateway nodes in this domain, domain 3 to be specific, are members of. All right. And last but not least, let's look at this route as it lands over in the remote domain. Again, we're going to look at it over here. We're going to set this color back to something that's easier to follow. There we go. And then this route is going to be over here on the spine. In particular, this MAC IP right here. Let's make sure we can see this. This is what we're looking for here. And once again, we see that the next hop is, again, the gateway node. We see the interconnect ESI associated with domain 5. We see the label as expected, the RT values, the NCAP is back to MPLS. So by the time this PE node over here receives it, it knows exactly how to forward the traffic, right? So all good to go. And then we'll have our end-to-end traffic communication. All right, so that was a fun little control plane packet walk. Let's go ahead and run some of these show commands now from from the HPE. So Sinish, back over to you.
Okay. Hello. So if you look at here, on the right-hand side, we are having 3 nodes from HP. One of them is MX, and another one is, the other 2 are PTX 10236 QBD. So I'm picking one of the PTX box as well as one of the MX box here. So show EVPN instance extensive. You can see here, I'm running with on MX 304, right? I have 3 more nodes in the Interconnect ESN. One is from the Nokia, nothing but 100.0.36, and 43 and 48 are other 2 devices. So if you look at the bottom portion of this one, you can see all other nodes part of the neighborship in the domain here. Okay. Now, coming back to the routes. So if you look at here, so BGP summary, I have one BGP peering towards the VXLAN node and one BGP peering towards the MPLS node, right? So let me pick the route which I am taking from the VXLAN node. So I'm receiving the type 2 routes from the VXLAN node, right? And the same route, right, I'll be advertising back to the MPLS world. Right? So this is with respect to the type 2 routes. Now, if you look at the type 5 routes, right, similarly, I'm receiving the type 5 routes from the VXLAN world. Right? Same thing, I'm advertising same back to the MPLS world. So the beauty here is, as and when the route received from the VXLAN world to the gateway, right? What exactly it is doing? I have a BGP route with a set of attributes, right? And the node will consume that route and it will do the reorigination, right? The reorigination happens in such a way that one side I have the VXLAN encap, the other side we have the MPLS encap. Those encapsulation type will change as the path attribute. Then the network will also change, right? When I advertise to the MPLS world, I will say that, okay, this is this is the node which you should reach out to me for this specific routes. So those will be now applicable for both type 2 and type 5 routes. Okay. So I'm just sharing with Hama for the show commands on the Nokia node.
Thank you, Sinish. So Nokia node. So I will try to show some command and configuration for our node, which is working as a gateway between the VXLAN and the MPLS. So router BGP. Sorry. So this is the MPLS. You see we have overlay BGP with the Arista MPLS. And for the underlay, we are using ZIS for the underlay. Also, we have BGP with VXLAN as well. So for the VXLAN, we are using 2 BGP, one for the underlay to export the system IP, which will be used for the EVPN networking. As explained by Mitch, that we have a layer 2 and layer 3. So I'll show you the layer 2 service configuration that we have. We have 2 BGP domain, one for MPLS and one for VXLAN. This is for the layer 2. And for the layer 3 service, we have as well MPLS and VXLAN. We are using domain ID with the DPass to avoid looping. And you see two root distinction and two root target for each instance. Also, we are using between Juniper and between HP and Nokia, we are using Interconnect Ethernet Segment. So this is the Interconnect Ethernet segment between HP and Nokia, which is all active, and we are using this service. That was the configuration in brief. Quickly, so some show command. We'll see in service, layer 2 service, we have VXLAN destination. You see, this is toward Arista, and this is towards Juniper as well. And for MPLS, we have also MPLS instance. So this is toward HP. Some layer 2 service show command for the FTP table. You see the MAC has been learned from two sides, from MPLS and from VXLAN. We can also do some root type 5 show command. See, this is the one that learned it via the VXLAN, VNI. You see VNI always here for all the root type 5s that we have learned. As well, we can do also for the MPLS one. So I change the root target to be 2000 and 2000. You see here, this all the prefix that has been learned. You see the MPLS label here. Last show command we can do to show the interconnect Ethernet segment between HP and Nokia. It's all active, and we are non-designated router. HP is a designated router, and this is all the DF node, all the candidate list of the nodes that participate in the DF election. I think that's it. I try to make quickly the configuration and the show command. Thank you.